Okay, for this one it's already factored, so we simply need a line for x and for x minus 5 and for x plus 2 and for the product of all of those. So here's a line for each of these. And the critical points occur here when x equals 0, when x equals 5, and when x equals negative 2. So we'll start with the negative 2, then 0, then 5. Okay, so when x is 0, then x is 0, and if x is bigger than 0, then x is positive. If x is less than 0, x is negative. When x is 5, x minus 5 is 0, and when x is bigger than 5, x minus 5 is positive. And when x is less than 5, x minus 5 is negative. X plus 2 is equal to 0 when x equals negative 2. And when x is larger than negative 2, x plus 2 is positive. When x is less than negative 2, x plus 2 is negative. So to complete this chart now, we simply multiply to get the product. A negative times a negative times a negative is a negative. Anything times 0 is 0. A negative times a negative times a positive is a positive. 0 times anything is 0. A positive times a positive is a negative. And anything times 0 is 0. And 3 positives multiplied together make a positive. So we now know everything about the product. When is it negative? When is it 0? When is it positive? So to graph the solution, we're graphing where are all the negatives or 0. Negative or 0 is what we're looking for in this chart. Because it's less than meaning negative or equal to, which means 0. So to graph the solution set, there's negative 2, 0, and 5. And we'll put circles around each of those. The negatives are to the left of negative 2 here. So we'll graph everything to the left of negative 2. Also, it's negative between 0 and 5, so we'll graph those points between 0 and 5. And also we're including the equal 0, so we'll fill in the points where this actually is 0, all of the endpoints involved. So fill in all of these points. And this one too. And so we have the graph of the solution set to this linear inequality. Now to write this in interval notation, we can think of negative infinity as being at the end of the line to the left, and positive infinity at the end of the line to the right. So in interval notation, you could write this as the interval from negative infinity up to negative 2, including the negative 2, union with the interval from 0 to 5, including both of those endpoints. So there it is in interval notation. And then in set builder notation, this is a set of all x such that x is less than or equal to negative 2, or x is between 0 and 5, including both of those endpoints. So those are 3 ways of expressing the solution set to this quadratic inequality.